Okay, so we spoke about quadratic equation and the solutions of a quadratic equation, that is roots, right? And we discussed one of the methods of solving the quadratic equation, that was factorization method, right? And let me take one more example of factorization, then we will directly move to the completing the square method. Okay, so let us take x square minus 2ax plus a square minus b square equals 0. Now in this case, the product that I require is a square minus b square into x square, right? And the sum that I want is minus 2ax. Or in other words, I need to split this term in such a way that the product of those two components gives me a square minus b square into x square, and the sum remains minus 2ax, right? So let us think about a square minus b square. What is a square minus b square? It is nothing but a minus b into a plus b, right? So there are these two components. I need to adjust or manipulate these two components in such a way that I can produce this term. Okay, so you can see that if I add these two, a minus b and a plus b, b will get cancelled and you will be left with 2a. Okay, so now if I write this quadratic equation like this, x square minus a minus b, a minus b plus a plus b into x plus a minus b into a plus b equals 0. Now you see this is nothing but 2a, right? And this is nothing but a square minus b square. So I have not changed anything in this quadratic equation. This is exactly the same as this one. Okay, now what you can do is you can write it like this: x square minus a minus b into x, right, minus a plus b into x plus a minus b into a plus b equals 0. Now first two terms you take x common, so you'll be left with x minus a minus b, right? And from here, if you take minus a plus b as common, you will be left with x minus a minus b, and put it equal to 0. Now again, let me make some space here. Okay, I think this much space should be enough, right? Now look at this. I can write it as x. Now you, from these two, from this entire equation, I can take this factor outside. So x minus a minus b I took outside. What I'm left with inside is x minus a plus b. Now it is equal to 0. Again, the product of two brackets is equal to 0. So either this bracket will be equal to 0 or this bracket will be equal to 0, right? So if I have to write the results now, x will be equal to a minus b or x will be equal to a plus b for this equation to be true. And what are the roots or solutions of the given equation? A minus b and a plus b are the roots of the equation that we started with. Okay, now let's directly come to the completing the square method. Completing the square method. Okay, I've discussed about this method in polynomials also, but I'll discuss it once again because now we are discussing about quadratic equations. Okay, so let me discuss it once again here, and I would require, I think, some more space, so give me a moment. Okay, let us start from here. Completing the square method. So let me write the standard quadratic equation that we started with: ax square plus bx plus c equals 0. where a is not equal to 0, right? And it is essential that we write a is not equal to 0, because we will involve this fact, we will use this fact to use this method, completing the square method. And if a is non, if we do not mention it and a becomes 0, then this is no longer a quadratic equation, so it is necessary that we mention it. Okay, so the first step that I'll use for completing the square method is the first step. Let me write the steps here. And first step will be to make the coefficient of x square equal to 1. And how can I make it 1? I can simply take a common. So if I take a outside, I will be left with x square plus b by a x plus c by a, right? Now you can also verify, if I multiply this a inside, I'll get this left hand side once again, and it is equal to 0, right? Now that a is not equal to 0, we started with this fact that a is not equal to 0. If a is not equal to 0, I can simply cancel it. Or you can think, if a is not equal to 0, then this expression here has to be equal to 0 for this equation to satisfy. So the next I can write is x square plus b by a x plus c by a equals 0. Okay. Alright. Now the next step of completing the square method. First step was make the coefficient of x square equal to 1. What is the next step? The next step that I am going to use here is add and subtract square of half of coefficient of x. What is coefficient of x? Coefficient of x in this case is b by a. What is half of coefficient of x? B by 2a, and square of half of coefficient of x is b by 2a whole square. So what I'm going to do here is x square plus b by a x plus b by 2a whole square. I'm going to add this, right? If I'm adding something on the left hand side, I'll have to subtract the same thing to keep the equation same, right? And then plus c by a equals 0. Why have I done this? Because if you notice, this has become a complete square now, because b by ax is nothing but, let me write it for so that you can visualize it easily. It can be written as 2 into b by 2a into x. And now look at this, a square plus b square plus 2ab, right? So this has become a plus b whole square, and rest of the terms I'll write as it is, b by 2a whole square plus c by a equals 0. So let us go to the next step. Let us write it in complete square form, that is x plus b by 2a whole square. And let us take, you can take this on right hand side also, so let us take it on right hand side, b square by 4a square. I have squared this and taken it on right hand side, so this negative sign will go and it will become positive, and here it will become minus c upon a. Okay, now the right hand side can also be written as b square minus 4ac divided by 4a squared, right? I've taken 4a squared as LCM on the right hand side. Okay, now so if x plus b by 2a whole square is equal to b square minus 4ac by 4a square, if I take the square root, what I can say about x plus b by 2a, it will be equal to plus minus b square minus 4ac divided by, this 4 will become 2 and this a square will become a, and b square minus 4ac you have to write in square root, right? So the right hand side will become square root of b square minus 4ac divided by 2a, right? I can give a special name to b square minus 4ac, which is d, and it is known as discriminant, right? This is a special name given to b square minus 4ac, which is discriminant or capital D, right? So the next step can be written as x is equal to minus b by 2a. I have taken this on right hand side, plus minus root d upon 2a, okay, where d is discriminant. All right, and if you want to write it collectively, you can write it as minus b plus minus root d by 2a. What is this? This is value of x, right? These are two values of x which satisfy the given quadratic equation that we started with, ax square plus bx plus c equal to 0, right? And this plus minus is nothing but, I can write it separately. I can write x is equal to minus b plus root d by 2a minus b minus root d by 2a. So these are two values of x, okay, which satisfy the given quadratic equation. So I can say that these are roots of the quadratic equation, okay. These are roots of the quadratic equation. Now I will talk about sum of roots, product of roots, and difference of roots. For that, if these two, I've already shown that these two are roots of this quadratic equation, right? Right. So if I add these roots, sum of roots will be equal to, look at this, the denominator is same in both the cases, so the denominator will be 2a, and numerator in this case is minus b plus root d, and in this case it is minus b minus root d. So when I add to take the sum of roots, this root d will get cancelled, and minus 2b by 2a, so it will be equal to minus b upon a. What is b? B is coefficient of x. So you remember this quadratic equation that we started with? B is coefficient of x, a is coefficient of x square. So sum of roots in this quadratic equation is equal to negative coefficient of x divided by coefficient of x square, right? Similarly, we can look at product of roots. So what were the roots? Minus b plus root d by 2a minus b minus root d by 2a. So if you want to find product of these two roots, it will be equal to, so the denominator will be 4a square, 2a into 2a, 4a square, and numerator is of the form a plus b into a minus b. So it will be minus b whole square minus root d whole square, which is equal to, and we are talking about product of roots here. So it will be equal to b square minus root d is b square minus 4ac whole squared divided by 4a square, and it can further be written as b square minus b square plus 4ac divided by 4a square. So b square will again get cancelled, and 4ac by 4a square is nothing but c by a, right? 4 will get cancelled and this a will cancel this, so c by a is the product of roots. What is c by a? Product of roots is equal to constant term divided by coefficient of x square in case of quadratic equation, right? So this was product of roots. Now let us talk about difference of roots. Difference of roots is another important concept. Difference of roots. So the roots that we are discussing here are minus b plus root d by 2a and minus b minus root d by 2a. Okay, when I say difference of roots, I mean that you subtract the lower value from higher value, okay, and I don't know whether this is higher value or this is higher value. So let me subtract and then I will keep the sign as positive. So for that I will apply modulus. Okay, let us say this is alpha, this is beta. So what I am going to find is the difference of alpha beta, right? If you subtract, let us say minus b plus root d by 2a minus b minus root d by 2a, you will see that let me simplify it, then you will understand. Minus b by 2a plus root d by 2a. This minus and this minus will make it positive, so plus b by 2a, right? And this minus and this minus will again make it positive, so root d by 2a. You see it, minus b by 2a and plus b by 2a get cancelled, and I am left with root d by 2a and root d by 2a, so that is 2 root d by 2a or root d by a, and I will write it in modulus sign, okay, because I am talking about difference of roots. So the difference of roots is root d by a. You can directly apply this formula and find the difference of roots. Okay, why have I applied this modulus, or why have I written this sign here is, when I'm talking about difference of 3 and 4, whether you do 3 minus 4 or 4 minus 3, when you do 3 minus 4 you will get minus 1, when you do 4 minus 3 you will get 1. But when I'm talking about difference of 3 and 4, it doesn't, the sign won't matter, right? You need the positive sign. You're talking about difference, higher minus lower. So if I apply modulus sign here and I say difference of 3 and 4 and apply modulus sign here, in both the cases it will be 1, which is true, right? So I need difference of roots in case of a quadratic equation, then I'll write mod of root d upon a. So this is difference of roots. In the next lecture we will talk about nature of roots, okay?